Please, another warm round of applause for our penultimate speaker, Sebastian Buczyński, Smart Contracts in Action.
Thank you. So, 60 terawatt hours. Do you imagine how much electricity it is? So I'll give you a hint. It could power 65 millions of 100-watt light bulbs to produce light for an entire year around the clock. Or a less abstract example, this is also a real yearly power consumption of an entire country, Switzerland, in this example. I guess that's a lot. And this is also an estimated power consumption of a Bitcoin blockchain, depending on the activity on the network, of course. And you might now be wondering about different questions. An average person would probably ask when this will be banned. And an engineer would ask, why? So I would ask why before I jump to the actual topic of this presentation, which are smart contracts. So I will give you an introductory course on blockchain, but it will be really simplified, just enough to grasp the idea of smart contracts after. So the blockchain might be a different thing depending on what angle we look at it. It might be seen as a network that is comprised of different nodes that participate and create this network itself. It also might be seen as a distributed database, which is an append-only structure, which consists of individual blocks, hence the name blockchain, because it's essentially a chain of blocks. And the actors that actually add to the blockchain are its nodes, and they also are all the time validating what's happening, meaning that the responsibility for making the data is consistent is also distributed. So we see it as entire network, not just like individual node. Not any one of them is superior most of the time. So the thing that consumes that lots of money is actually what nodes do. They mine, meaning they are doing computationally expensive tasks to one of two things. One, confirm that everything is consistent, and second, to add new data to blockchain. And the reason is, why would anyone spare their computing power for doing computational tasks that most of the time does not make any sense? They are not like working on a new cancer treatment. Is, of course, money. And this is connected to the reward system of the blockchain, an incentive that makes nodes and encourages them to participate in the network. Depending on the blockchain, the rewards may vary, but usually this is a currency that is dominant in a specific blockchain. So in Bitcoin, obviously it will be Bitcoin. Let's talk more about validating state. So whenever all nodes agree, or at least majority of nodes agree on the current state of the blockchain, we are speaking of consensus, meaning they are in some kind of agreement, because obviously these are servers outside. But this consensus, which is distributed just like the responsibility, provides the biggest selling point of the blockchain. And this is not cryptocurrencies. This is so-called trustless. And it doesn't mean that the blockchain is not worthy our trust or this is dangerous. It means that there is no single particular node that or single particular institution that we have to trust to be sure that what the blockchain is keeping is safe. And there are many different blockchains out there. Bitcoin is just the biggest one, at least in terms of market capitalization and perhaps in the power consumption also. The second biggest is Ethereum, and we will devote more attention to it, but later in the second part of this presentation. Dash, Litecoin, Ripple, Stellar, and there are more blockchain appearing every few days, I guess, or maybe months. And the place when all of these blockchains mean, because they obviously are separated networks, are crypto exchanges. And I guess that's probably the first thing that you come to your mind when you think about cryptocurrencies or blockchain specifically. So a part of being a perfect place when you can exchange one tokens or crypto coins for another, this is also a very efficient way to burn all your money. But the blockchain could be so much more. But it doesn't seem so when we only think of it in terms of like a dump append only database being a ledger that just contains data about transactions, like Tomek sent his money to whoever. The blockchain can also enable us to model behavior. But before I jump into speaking of what smart contracts are, I have chosen 3 interesting, at least in my opinion, projects that can explore different applications of the blockchain that doesn't actually amount to just throwing your money away. So imagine a challenge for now, like turn off all your ad blockers and enter a page that either is about gossiping or tries to catch the user's attention with some sensational news that doesn't actually change anything in your life. So that's a very common picture today on the internet. And the project that tries to turn the tide in this case is a combination of basic attention token and a Brave browser. So what is the current state? So whenever we have some publishers who creates a content that's actually worthy and would like to sell this, obviously he won't make any revenue if no one knows about this project. He goes to advertiser ordering a campaign, and the advertiser is then responsible for running the campaign. So he goes to the middlemen, which are companies like Facebook, like Google, who can rent you a space for ads and perhaps also let you target these ads for a specific types of user. But the user here is a victim of this arrangement because he's not making any profit out of this scheme. We are literally bombarded with ads we don't actually want to see. And so to mitigate this, we learned how to install ad blockers. And this makes things worse because obviously ads are less efficient if the great deal of people just blocks them. Publishers makes less revenue, and also the advertiser has to put more. The only winner in this scheme is the middleman, so the one who earns or tagging. So the basic attention token is just like what it says. It tries to tokenize the user attention, so everything starts to revolve here. The user are rewarded, basically. Basic attention token is just a representation of a value of a user's attention. So obviously, no longer it is necessary to let anyone gather your data. You can only make your data available for ad targeting, but only if you want to, and you will receive some basic attention token in return. The advertiser may also reach to the people who agreed on this, and not just doing blind shots. And also, since the advertising would be more effective, the publishers would also make more revenue. Of course, in theory. And the second part of this is the Brave browser. I saw Christian Użycki having this browser installed, in fact. So this is basically a usual web browser, but it has all the ad blockers already installed. And it also tracks what are you doing, but it's not sending them elsewhere to some great company place in the US. It just makes sure that the publishers are getting basic attention tokens for attracting users' attention and for providing valuable content. So that's one project. The second is a New York-based startup related to energy market, and it's Project Energy. So historically, humanity has been producing electricity for since second half of the 19th century. It is very centralized process. We manufacture energy in giant power plants, then we transfer it to the consumers. But nowadays, more and more people are installing solar panels or putting a wind turbine somewhere in their land. So we are not only becoming the consumers of the energy, but when we are actually producing more energy than we are consuming, then the term is prosumer. So the Exergy, this startup, has figured out that we would actually not want to get rid of power companies in this picture, but we would like to relieve them from the need of managing these local prosumers, because since it's blockchain based, we could get a marketplace when you could buy an energy from your neighbor, and this would obviously be cheaper than send it from a power plant that's located a few hundred miles further. And the last project I wanted to share with you is a medical chain, but they have a nice explainer video, so I won't attempt to explain it better than this.
One of the biggest problems in healthcare today is that organizations hold multiple and fragmented health records about patients. Medical Chain solves this problem by putting medical record transactions on the blockchain to create a smart healthcare ecosystem. With Medical Chain, a smart contract is launched to give time-limited access to a patient's electronic health record. Doctors write notes, add scans and lab results, which are all recorded as transactions. The pharmacy dispenses medication and also records the transaction on the blockchain. The patient gives time-limited access to their insurer for verification of treatment and payment settlement. With smart contracts, patients reward doctors to remotely review medical cases and provide advice or a second opinion. Patients give health insurers access to their health record to monitor fitness progress and be rewarded with tokens or a reduced insurance premium. Patients are also rewarded for giving research institutions time-limited access to their health records for medical trial purposes. Medical Chain is issuing med tokens, which patients will use for storing electronic health records on the blockchain, data from wearable fitness devices, and transfer value and payments. Medical Chain's healthcare ecosystem will be a platform for developers to build smart applications that analyze health data and provide recommendations such as nutrition and fitness routines. We are a real company driven by doctors worldwide and the blockchain community.
Okay, and that's enough, because otherwise they should grant us some basic attention tokens. Right. So getting back, so the common knowledge is that blockchain is merely a data and it's only connected to transferring money. Well, this is not true, because what puts these businesses in motions are blockchain behaviors, which are materialized in a form of a smart contracts. Before I show you what are the true colors of smart contracts, let me disappoint you, and twice. So first, these are just computer programs, and there's really nothing mystical about them, just the unusual environment they run in, which is blockchain. And the second thing is that they are not smart in any way. They can be only as smart as a person who programmed them, and not more. So the rest of this presentation is specifically about Ethereum smart contracts, which have some these few distinctive features, but also are most widespread. So before we delve into code, which I must warn you will be a lot in this part of this presentation, let's talk about accounts on the Ethereum blockchain. So a usual account will have a wallet. And the wallet you can store the cryptocurrency in. In case of Ethereum, it's Ether. So a wallet is something that you possess, that you have a private key to access it to perform operations like withdraw or send this Ether elsewhere. The Ethereum smart contracts are also accounts in the meaning that they can accumulate and store Ether, but you do not have a private key to do whatever you want. If you would like to, for example, withdraw the Ether, you have to program it. If you would like to any control, you also have to program it. But the key point is that Ethereum smart contracts also possess Ether, just like the wallets. But they don't have a concept of ownership unless you program it. So the smart contracts, since they are computer programs, they have to be written in some language. And the language of Ethereum smart contracts is Solidity. So Solidity is statically typed language, but it's actually quite low level at few points. You will see just in a moment. So a contract in Solidity is just like a class or a function. It's a language construct. And these smart contracts can, just like anything on the blockchain, contain state. And the important thing is that this state is preserved between smart contracts calls. So in other words, when I call smart contract for the first time, I change something in these variables and I invoke it for the second time, the state is preserved, so I still have it. We can use primitive values, like in this time unsigned integers. There can be lists of addresses. there will be mappings which are Python's equivalent, which are solidity equivalent of Python's dictionaries. And we also need to model the behavior. So each smart contract can also have a functions or methods, however you call it, if you like the analogy of a class. So the special one is like the constructor, which is invoked once when the contract is deployed on blockchain, like created. They can be private functions that are not visible outside the contract but can be used inside. Or there are modifiers that can allow us to implement, for example, permissions in a developer-friendly way. For example, whenever I declare such function, I could add this after the different functions definition, like payable in this case. So instead of crawling through theory, let's do the real example. A crowdfunding. I guess you are all familiar with platforms like Kickstarter, when people announce their new exciting project that it's meant to change everything, but they need just your money to actually make their dreams come true. So we'll make such a crowdfunding project right now, but with the difference that there won't be any organization like Kickstarter involved. So there won't be any middlemen that would need to charge some fees, thanks for the service they provide. So obviously I would like to have some state for this crowdfunding project. And I will surely want to keep how much money I would like to raise. I would also want to track how much I have raised so far, when it will end, because such fundings do not usually last forever. They actually never last this. And also I would like to keep a mapping of what are the backers who decided to support this project. Regarding the behavior, the functions, I would like this to be reusable. Whenever I want to launch a new project or a new crowdfunding, why won't I write this from scratch? So let's reuse it and parameterize the logic with two basic parameters, like how much ether I want to raise and how long I would like to this crowdfunding to last. And the most interesting part of this contract is obviously a function back project. So this is something that users wanting to back the project will invoke. And this modifier payable means that apart from only invoking the functions, they can also send ether with it. Otherwise, it would be rejected. So then we have this. Surely, we would like to check some conditions, which, if they are not met, we would like not to proceed. So require is like assert, we just abort the execution if the condition is not met. Then we would modify our internal savings. Notice this magic message. This is an implicitly passed argument which just refers to whoever launched the contract. And finally, we remember who actually supported the project. There is also one special function, which is this function doesn't have a name. This is called a fallback function. And it's particularly helpful, at least in this case, or if you are writing a malicious contract to stall funds, which I'll show you in a moment. Because whenever someone just sends ether, because like I said before, smart contracts are just accounts. They also have addresses, just like individual wallets. So at some level of abstractions, they are indistinguishable from a different accounts. So if someone would send an ether to such a contract, it could be lost forever, and you would not have a track of what happened. So implementing such a fallback function is usually a very good idea. We'll get to this later. So as I said, the smart contracts doesn't have any notion of ownership of access control. If you want one, you need to implement this. So I will do it simply. I will just remember who created the contract. I will keep it in a variable of type address, and during construction, I will just assign it to whoever actually deployed the contract. And whenever this crowdfunding is finished and the goal was reached, I would like to get this ether to do something about it, as I promised initially. And of course, I would like to check if I am really the person who claims to be the owner. So this is this condition which ensures that. And the one final thing, this is a very important construct, and the function self-destruct has two different purposes. At first, it will, just like it says, destruct the contract. It make it no longer usable. So no one would ever can interact with the contract again. And the second side effect is that all the funds that were accumulated on the smart contract are sent to the address that is passed as the first argument, which obviously be the owner because we checked it one line higher above. So what we've got here is a decentralized crowdfunding, basically. It seems to be a mostly feature complete. And as I said initially, we don't have any middleman in this process involved. No one guarantees that the money will really reach the person who started this funding, and we don't also need any institution to make sure that the money will get back to the backers once the funding has not succeeded. This is what blockchain guarantees us in this case. So software developers are probably now itching themselves to write some smart contracts, because the best feature about it is that this is a fully Turing complete language that you could model, implement any behavior desired. But now the software testers are a bit crippled because of bugs. Because since this is a computer program, and we know it very well that it's difficult, extremely difficult to write it without any flaws. And this is also the case in the smart contracts, and they can cause very severe security holes. One of my favorite, if I may use such a term, is the origin of the Ethereum classic cryptocurrency and blockchain. So, as you might figure out, it has something to do with Ethereum. In fact, they were one blockchain in the past, but something bad happened. Once upon a time, in 2016, there was a creature called DEO. So it was basically a venture fund for future blockchain projects. So anyone could send their Ether in, and the DAO was supposed to fund the projects which were prospectful for the blockchain future. Unfortunately, there was a bug. And as a result, the hacker was able to stall 1/3 of the funds accumulated, which was 14% of the Ether back at the time, and given current price, it was $150 million. So there was a schism in the community. So a part of the guys wanted to just undo this. Okay, this is serious, which is basically what you don't do at blockchain. You don't undo the history. It happened. So the guys who agreed on this undoing remained with the original Ethereum, and the guys who said, no, this already happened, it's blockchain, they formed Ethereum Classic. So this, of course, the DAO haven't survived this and no longer exists. So I will show you how easy it is to introduce such kind of vulnerability. So let's say we want our people to have an ability to withdraw their funds if the funding was not successful, the goal was not reached. So of course we check if they actually have something to withdraw. Then we send the money, and then we zero the internal state, which of course, I mean, maybe not of course, but this is a re-entrance attack vulnerability, what you can see here. Because it's not only that people or usual users may call smart contracts. The smart contracts can also call themselves. And in this case, I might have sent some funds to the crowdfunding from a malicious smart contract, then ask for a withdrawal, and implement a fallback function that will just call this again. So you see the problem. It will just loop in here with a recursion until I could drain all the funds, or at least, I don't know, like get twice as much as I paid in. So the secure version looks like this. We just need to remember what we are supposed to withdraw, change the internal state, and then call it. Of course, the security is a serious concern. There are several countermeasures to mitigate any risks. So first of all, there is a static code analysis. Even this code that I presented earlier has several issues, so please don't use it in production. So of course, there are a bunch of tools who does this. Also as a services in cloud, because why not? You can also subject your code to the security audits doing by third parties, or you can resort to formal verification, which has more to do with maths than programming actual, because it's a form of proving that under any conditions with any possible internal state, the invariants will remain correct, meaning it has no bugs, but mathematically. So I have three key takeaways from this presentation when it comes to smart contracts, and if you ever face to write one. So first, keep it simple. Due to two reasons. First, the complex programs are more error prone, and the second one, you also pay in Ether for executing logic in smart contracts. So yeah, like looping forever is not a good idea. And the perfect use case, perfect niche for blockchain-based application of smart contracts are those when you can either cut out the middleman completely or diminish its importance or influence, just like it is with XRG, medical chain, or the basic attention token. And the last but not least, don't you ever take security lightly with a smart contract. Thank you.